This is Unit 8, Lesson 8.4, Probability and Area. Probability and Area. Don't forget a date, time, location, as well as a parent or guardian sign-off. For this problem, I'd like you to read it out loud. You're going to do this entire page on your own. Pause the video, restart when you're ready to go. Pause. Welcome back. So it says right here that PWQ is 60 degrees. Radius is 9. So this should have been 60. There's circumference here in pi form. C equals 18 pi units centimeters. Area is going to be pi r squared. So it's going to be 81 pi centimeters squared. Arc length is going to be a fraction of the circumference. And sector area is going to be a fraction of the area. Let's see how you did it reducing these. That's 6 times 3. The answer here, 3 pi centimeters. That's arc length. That's going to be 6 as well. And 3 goes in there twice. 3 goes in there, what is it, 27? Yes, 27. Sector area is 27 over 2 pi centimeters squared. So today we're going to continue talking about area. We're going to contrast what is the difference between normal shapes versus composite shapes, regular shapes, something called negative space, part over whole, and probability. You're going to want a calculator. Normal shapes are just your single shape items that you can name as a single item, such as a triangle, a circle, a trapezoid. Then you have your regular shapes, which are a type of normal shapes, where all sides and angles are equal. So, for example, we have a regular pentagon. Regular octagon. Then we have what are called composite shapes. Composite shapes, think of the word compose, like music. Composite shapes are shapes made up of a combination. For example, this shape here is made up of a semicircle and a triangle. This shape here is made up of course, 2 distinct rectangles. So that's a composite shape. Now we've learned area equations for each of these guys. Those are your area equations. You want to copy those down, of a triangle, a circle, and a trapezoid. And of course, irregular shapes is PA, perimeter times apothem over 2. What's different about these composite shapes is there's no singular equation to find those areas. Instead, they are going to be composed of a combination of things. That's why they're called composite shapes. So composite shapes are composed of multiple normal and regular shapes. It's important that you see the shapes as both a breakdown of smaller shapes as well as something called negative space. Let me give you an example of what I mean by this. Breakdown of smaller shapes and negative space. If I want to see the area of the shape below, I can see it as a combination of 2 rectangles. We could slice it down vertically, or I can slice it across horizontally. You're going to get the same area either way. So let's go ahead and use this horizontal component, which means I'm going to have one rectangle and another rectangle. The area of this first one is area equals length times width. It is super important that you physically trace the length and width here. Ready? Length, width. $12 feet square. That's our one area. Area down here. Let's physically trace your length and width. Length. Physically trace it. Width. Careful. Your width is not 5. Look very carefully. Your width there is only from here to here. This whole side is 5. And then right here, this is 2, which means that's 2, which means what's left, the width is 3. That's why you physically trace stuff. Don't let your eyeballs do the work there. That's 9. So my composite area is going to be 12. 12 plus 9, 21 feet squared. So that's one way to look at a composite shape. It's a combination of smaller shapes. Another way to take a look at it is what's called negative space. So I can look at this as one giant rectangle. And then we're going to take what's called the bite out space. Let's find the area of this. So this one, I'm going to draw a thing equation. It's going to be that larger rectangle minus the bite out. And that's going to get us our leftover space, which is the green. So our larger one, that's going to be 6 times 5. Of course, it's 30. Minus, we go like this. Physically trace. This whole thing is 6, 3, 6, 3, which means this is 6, 3. That edge is 3. Use your finger. 5. That's 5. That's 2, which makes this also 3. So 3 times 3, 9. 30 minus 9, 21 feet squared. Notice it's the exact same thing. So you can see the smaller pieces, or you can look for what's called negative space. And negative space, larger subtract the smaller. If you want a large version of this image, it's also in your reference booklet. So if you want to put the next problem in your reference booklet for easy keeping, you're welcome to, or you can work it here, transfer it later into your reference booklet. So when you're working with composite shapes, it's important to do thing equations. So this entire shape, let's just trace this whole shape. This entire shape, like a little baby version of it, is equal to a half circle added to a triangle. So we have to find the area of both. Let's write your area equations. Area of a half circle. Apple pie is really, really good. And then half plus, this is going to be base area equals base times height over 2. So we're going to take this one step at a time. We're going to end up getting both these areas are semicircle area and our triangle area. We're going to add those two together. Let's start with the one that functionally has something, and that's the triangle. I'm going to bring the triangle down here. Notice it has 3 equal sides. If it has 3 equal sides, it has 3 equal angles. And we want base times height over 2. My base is going to be the blue squiggle. Height, careful, your height is not 36. It's that line at a right angle, base times height over 2. So if this is 36 on this side, this is 36 right here. So I just found my base. My base is 36. Problem is, I don't have my height. But I do know that this base, if it's equilateral, is going to split this in half. So this edge right here is going to be 12. 2 things we could do. You could either use SOHCAHTOA, but we do have ourselves a 30, 60, 90, short leg root 3, short leg times 2. Going this way times root 3, going this way times by 2. So my height is going to be 3 root 3. No, not 3 root 3, excuse me, 12 root 3 over 2. I'm going to go ahead and reduce. You go 36 times 6. I get 216. Root 3. Now, because we have to add it to something else, we're going to get it down to a decimal. I'm going to start by doing square root of 3. There's my decimal. Times 216. Have your calculator handy too. See if you can get the same thing. Take it to the second decimal place. 374.12. So I found one of my two areas. 374.12. Now for my semicircle, all I need is a radius. That one's easy because if this is 36, it's equilateral, that's 36, which means our radius is half of 36, which is 18. I'm going to do my math down here. 18 times 18 times pi over 2. So 9 times 18. 162 pi units squared. Now, because I have to add it to something else, I'm going to get that down to a decimal. Second decimal place, folks. $508.94. So we got 508.94 there. And then you simply add up composite shapes. So I have 508.94 plus 374.12. And we got 883.06 as your total composite area. Check for units. There doesn't seem to be any units, so we can say unit squared. So to recap, please label this. Always start with a thing equation. Thing equation. 2, write out your area equations. 3, make sure you show your work. And then in general, the step 4 is you're going to be adding composite areas together. This, by far, is the most critical step, are the thing equations. Things before algebra. Okay, now we're going to deal again with the composite shape. We're going to add the concept of geometric probability. Geometric probability is simply put the area of a potential something compared by division to the area of the whole. So our first thing is we're going to find the area of the shaded region. Let's make our thing equation. Our thing equation is going to be a rectangle minus or take away a rhombus. A rectangle minus a rhombus. Now we are told that each vertex, that's these guys, is 1.5 units away from the side. So let's just go like this. Each of those edges are 1.5. Let's write our area equations. Area of the rectangle, length times width. Area of the rhombus, diagonal times diagonal over 2. The rectangle here is easy. Length times width. Physically trace it with me. It's going to be obviously 10 times 6, which is 60. Check for units. We don't have any units squared. Now, let's draw in our diagonal. We have 1 diagonal, 2 diagonal. Now, to get that blue diagonal, I'd like you to trace from there all the way. Notice that length is 10. And then you're going to go in 1.5, in 1.5, squiggle it. That means that squiggle diagonal, the whole thing is 10 minus 3. So it's going to be 7. So one of our diagonals is 7. Times our other diagonal. Trace all the way from here to here. That's 6. You're going to go in 1.5, in 1.5, which is 3. So 6 minus 3. That means our other diagonal. Whoops, minus, not plus. So one diagonal is going to be 7. The other diagonal is going to be 3 over 2. Now we're going to find the area of our shaded region. And of course, that's 21 divided by 2. We get 10.5. So 60 minus 10.5. That's 49.5 is the area of our shaded region. Always label. So we're asked, what is the percent probability that in any random point would be in the shaded region? So anywhere in the shaded region, what is the percent probability compared to the entire rectangle? Notice, shaded region compared to the entire rectangle. So to get that, that is a fraction. Area of potential over area of whole. Our area of potential, which is our shaded region, is 49.5. Our whole rectangle is 60 units squared. So to get the decimal, we're going to go 49.5 divided by 60. You're going to take it to the second decimal place, 0.83. So there is an 83% chance that a point will be in the shaded region, which is area of potential over area of whole. Let's do one more problem together, and then you're to do one on your own. Again, this problem's in your reference booklet, so either you can go to your reference booklet and just follow along there, or work here and transfer it later. It says find the probability that a point lies in the shaded region compared to the entire square. Now, remember, probability is going to be area of potential over area of hole. Our area of potential is the shaded region, and our area of hole is the entire square. So ready? Now we're going to do a thing equation. To get the shaded region, we have to find the area of this square minus the area of four, I'm just going to write 4 circles. Now let's make your thing equation. Area of this, since it's a square, is just side squared, minus 4 pi r squared. Our length and our width here, of course, is going to be 6 times 6, 36. Check for units, unit squared. Now, the only thing you need is a radius. Let's draw a radius. There's a radius. We can use that radius, this radius. It doesn't matter. You need a single radius. And you're like, wait a minute. There's nothing there. I'd like you to put your finger right here. I'd like you to physically trace down there. Ready? I'd like you to physically trace down this side again. That's 6. Come over here. Trace that. That's 6. Trace, boom. That's also 6. Which means we go like this. Your diameters have to be 3 and 3. Which means your radius is 1.5, folks. All right, now you can get your calculators out. Follow with me on your calculator. I'm going to start by squaring the radius, 1.5 squared, times by the pi key. And now I have 4, so I'm going to times by 4, take it to the second decimal place, 28.27. 28.27. To find the shaded region, now we simply subtract 36. We get 7.7, take it to the second decimal, 7.73. Units squared. Box that, label it. That is the shaded region. Now to get the percent probability, it's area of the potential, which is the shaded region, over the area of the hole, which is 36. You take it to the second decimal. It's 0.21. So that is approximately 21%. Once again, same steps. You make a thing equation. You write your regular equations, your area equations that go with it. And then you just do your number crunching from there. I can't emphasize how important it is to make a thing equation before your numbers. Things before numbers. This page, you're going to read and do this completely on your own. I should see evidence of correcting with a red pen or a different colored something. If you get it right, I expect a star or smiley. If there's some part of this you get wrong, that's perfectly okay. I expect a note and a redo in the margin. I must see evidence you did this on your own and then correct. Pause the video, do your own work. Welcome back. We're going to find the area of the shaded region. And our thing equation, obviously, is going to be a circle minus a square. And that will get us our shaded region. Our equations, so we have a circle, pi r squared, minus, here's our square. Now remember, a square qualifies as a rhombus. So a rhombus is going to be diagonal times diagonal over 2. Diagonal times diagonal over 2. So we have our circle and our square here. We are found the area of the circle, and we're going to minus the area of our square, and that'll give us our shaded region. So you should have done this work already. Get your red pen. Let's check it. Our radius, it's really obvious. It's 16. So we're going to go 16 squared times pi minus our one diagonal is 16 times 16, or 16 plus 16, that's 32, times our other diagonal, 32 over 2. We're going to get both these numbers. First one, 16 squared times pi, 804.25. 804.25. This one, I'm going to go 32 times half of 32, which is 16. 512. You get your shaded region. I've got 292.25 is your shaded region, 292.25. 292.25, box it, you should have gotten your shaded region. Now we want the percent probability that a point will be in that shaded region compared to the entire circle. So you're going to take that shaded region and divide by the whole, which is 804.25. That gets you the percent probability that your point will be in there. It's essentially 36%. Students, very, very helpful. Take 2 minutes, set your phone timer, verbally summarize the basic content, or just quickly rehash how to do each problem. This 2-minute rehash will help not only increase your comprehension, but also your retention, which is the memory over long-term, comprehension over long-term. Set your phones again for 2 minutes. Do the recap on your own. Go.